our academic lecture on engineering this evening. We'd like to welcome Dr. Castro from the University of Bath, who's going to be giving us a little bit of a talk in a little while. If you have any questions about engineering or about University of Bath in general, please just pop those into the chat as we go along, and we'll pick those questions up at the end of the lecture. Siobhan's here with us as well to answer any more general questions about the university itself and those sorts of things. Siobhan helps look after the students from Southeast Asia when they arrive at University of Bath. Dr. Castro is a lecturer in chemical engineering and is also part of the admissions team for the undergraduates for chemical engineering. So it's a pleasure to have you with us tonight. And I'd like to just hand over to Dr. Castro to get us started.
Excellent. Thank you very much. Good afternoon, everyone. Good morning in the UK, and well, good morning to me as well. I'm actually at the moment in Mexico. So we are across the globe, which is fantastic with technology. And of course, welcome to the University of Bath talk. I will give you a little bit of an introduction of who we are. Just wanted to highlight that you can always look at the University of Bath website, and also something to point out is that the University of Bath is the University of the Year for 2023, which is, we're really proud of it. Anyway, let's just start with a little chat. Hopefully you can see my screen. At the moment, you can probably see an image of myself with a parrot in my head. And the whole purpose is just to introduce myself. So I am Dr. Bernardo Castro Dominguez. You can just call me Bernardo, perfectly fine. I am a lecturer. I've been doing lectures at the University of Bath for close to 6 years. And I'm also director of undergraduate admissions in chemical engineering. A little bit more background so that you know who's speaking in front of you. I am a chemical engineer by training. I did my degree in the US. I did a PhD at the University of Tokyo, and I've worked in the US as well as in Ireland in the area of pharmaceutical manufacturing. And currently, of course, I am doing research as well as teaching at the University of Bath. So that's who I am. And I'm going to try to inspire you and let you know why engineering is the best way to go and why Bath is a really good training center for you. All right. So why Bath? Let's take a look a little bit about Bath in general. So Bath is a UNESCO World Heritage City. It's in the southwest of England. Perhaps you are already familiar with it. It is 80 minutes to central London by train, 2 hours from Heathrow Airport, and only 12 minutes to Bristol by train. Now, a cool thing about Bath is that it is a small town. There's approximately 100,000 inhabitants, and 30% of those are students. So here is a fantastic student city. And something to highlight it is that it is the safest university city in England and Wales. So it's just amazing to be there. Bath has a lot of historical sites. It is a very lovely city. As I mentioned, it is UNESCO World Heritage, and perhaps you know it best because of the Roman baths, which you can see in an image here. That was built by the Romans quite a long time ago. So this is Bath, and this is our campus. Our campus is located approximately about, 2 kilometers from the city center. So it is not far. I personally walk every day. It's on top of a hill, which might be a little bit challenging for some. But it is lovely. As you can see, we have a city camp, a campus university. So everything is within the same area. We have amazing sports facilities. We have accommodation as well. And of course, here in a red rectangle, perhaps you can see it, is where I am from, which is the chemical engineering department. So this is a comment from one of our students from politics and international relations. Annabelle said that the good thing about the university is that you're surrounded by so many students that you don't ever feel isolated. So Bath, it is amazing because you actually feel within a community. It's a campus university that makes you have that feeling of a community. You will meet people from different departments, different faculties. So it is a really enriching experience. All right, so this is Bath, this is our campus, but what do I want to communicate to you today? The key messages for today is basically, I want to give you some insight so that there's a career success for any engineering students today. In particular, I would like to further your understanding of what is engineering. The second one is we're going to tap into something called the Sustainable Development Goals. Just wondering really quick, if you can put your hands up if you know what are the Sustainable Development Goals. Anyone in the chat, please put your hands up. I can see you right here. So hands up if you know what they are. All right, we have one. Excellent. Well, I will describe that further because that should be a very powerful motive of why you want to study engineering. And the third key message is why engineering at Bath. We're going to talk a little bit about, I'm going to show you very briefly our entry requirements, a little bit about our program structure, and we're going to discuss something very powerful that we have, and that's our industrial placements. Okay, so let's jump in. A quick disclosure is that you might be interested in other engineering besides chemical engineering. However, to show some examples, some more concrete examples, I will always tap into my home engineering, which is chemical engineering, okay? All right, so engineering as a profession. So there's been a lot of comments from many people and a lot of definitions. Some are here on the screen. Let's read a few. It says, someone who has good understanding of the fundamental science and mathematics and apply these laws to solve problems. Okay, so engineers solve problems. That's great. Someone who is creative, ingenious person who finds solution to practical problems. Again, comes this thing about solving problems. Someone who brings good ideas to reality. And then the last one is someone who considers sustainability, ethics, safety, cost, efficiency, reliability when designing the products, processes, and services. So we solve problems and we try to make things that are useful for society. So in general, if you think about it, engineers make the world a better place. So that's a very powerful statement. And let's go more in depth. So what else do we engineers do? So I was looking back in 2019, why engineering is so powerful. And I found this article online that says engineers are the reason many of us are alive. And I was like, really? I really started studying numbers about how have we changed people's life. And in particular, I focus on chemical engineers because obviously I'm a chemical engineer. And let's take a few, let's see a few names. So we have Abel Wohlman. Abel Wohlman, I was reading, started doing some water chlorination in large scale to kill pathogens from drinking water. And it has estimated that roughly saved approximately 177 million lives, which that's positive. Let's take a look even further. Harvard and Bosch, well, they started the nitrogen fixation process. Nitrogen fixation, we take nitrogen from the air, we take hydrogen, and then we combine them to create ammonia. Once we have ammonia, we can use that to make fertilizers, which we can put to plants, grow more crops more efficiently, and then we can sustain the nutrition for the world. And it is estimated that this process has saved approximately 2.7 billion lives. All right. And then, of course, Margaret Rousseau, she was a chemical engineer who started the mass production of penicillin. And well, thanks to her, we have there's been billions and billions that are being saved even today because of this mass production. Okay. So chemical engineers and engineers in general make impact in the large scale. Okay, so we save lots of people. There's a few quotes from different scientists. Isaac Asimov, it is engineering that changes the world. Scientists dream about great things. Well, engineers do them. Engineers operate at the interface of science and society. And finally, perhaps you know the scientist at the bottom left, Albert Einstein, who said, scientists investigate, which already is, but engineers create, which has never been. Okay, so that should be very inspiring. We create things to make a better, the world much better. And of course, there is lots of different engineerings. Okay, this is just an overview of what we offer at Bath. We divide the different areas in 4. Nonetheless, there is subgroups that you study within these big groupings. We do mechanical engineering, electrical engineering, chemical, and civil. Okay. In mechanical engineering, you deal with things related to aerospace, automotive, manufacturing, design, systems, nuclear, integrated systems, as well as materials and marine engineering. Okay, so if you're interested in any of these engineerings, they fall within the mechanical spectrum. When it comes to electrical engineering, electronics, computer engineering, software, communication, power, and control and instrumentation are things that fall within electrical engineering. When it comes to chemical engineering, biochemical, petroleum, environmental engineering, and material science, everything falls within chemical. And then civil engineering is all about structural, biotechnical, environmental, building, and water resources. Okay. We're going to talk a little bit more in depth into each of these subclasses that we have, or different groupings, so that you have a better understanding of what each of these areas of engineering are. Let's start with civil. So civil engineering is the broadest engineering discipline that specializes in designing and constructing for infrastructure. So really, if you want to make impact into the infrastructure of anywhere, here we have some images about Malaysia. If you really want to make amazing buildings, amazing structures, really help the development of cities, for example, building construction, transport systems, water resources, etc., civil engineering is the path that you want to take. Now, electrical engineering, okay? It focuses on design, develop, test, and supervise the manufacture of electrical equipment, such as robots and automated machines. A lot of our electrical engineers work in areas related to aerospace, electric motors, machinery controls, electric utilities, wiring in buildings, communication, and software and control, okay? Something to say is that engineering is becoming so interdisciplinary that the fact that you work only in electrical engineering does not mean that you cannot combine it with civil engineering or with chemical engineering or with mechanical engineering. They're interdisciplinary, but each degree gives you an emphasis in these particular subjects. Let's take a look at mechanical engineering. So mechanical engineering is one of the most versatile disciplines in general when it comes to engineering. And it focuses on mainly using 2 things. One is thermal energy, the use of heat to move things around. And of course, machine design, okay? So using these 2 big things, thermal energy and machine design, mechanical engineers focuses on advancing cars, trucks, aircrafts, industrial equipment. They work along with electrical engineers to make robots, heating and cooling systems, medical equipment, materials as well, and manufacturing, okay? And then here we have where I am from, which is chemical engineering. And we usually define this in a very simple way. I put here my definition, the one that we use always is making better stuff from ordinary stuff without making bad stuff in a safe and cost-effective manner. Okay. In other words, we make things sustainable. And the way we define in this case sustainable is enough for everyone forever. Okay, so it's a beautiful terminology that we use in chemical engineering. And in chemical engineering, we focus on many, many things. If you think about stuff is very broad. It's many, many things that you can actually, everything you see, from computers to cars to energy to pharmaceuticals. In here are some examples. We focus on working hydrogen to energy, using petrol from crude oil to develop different polymers, plastics, biodegradable plastics, which is a big area. We want to make it more sustainable, drinking water, antibiotics from bacteria, cosmetics, food and beverages, heating systems, piping networks. It's just amazing the range of things that you can work when you relate to stuff. Anyway, I just get excited when I talk about chemical engineering. So beyond engineering, engineers not only focus on that. Engineering is a way of thinking. It's a way of training. It's a way of approaching problems. If you remember, our definition of engineering is about solving problems in a creative manner. So engineers with a degree in engineering, you guys can follow any path you want. You can do project management, banking, financial services, procurement and supply chain management, commercial management, international business, human resources, sales and marketing, and many, many more. Okay, just to give you an example, I myself worked for a little bit in the US, doing working for the US Department of Energy, trying to shape the policy of carbon capture. Even though I'm a chemical engineer by training, due to my expertise, it allows me to shift different fields and really focus on trying to see how much should we tax industries for CO2 to incentivize the adoption of cleaner technologies. So it is engineering is very versatile. It's all about how you apply your logic, your reasoning to solve problems, and you can apply them everywhere. Other areas where you can work, as you can see here, is manufacturing, engineering, policy making, environmental, biomedical, and as I said, banking, journalism, and even digital technologies. So yeah, the world just got really, really big with an engineering degree. Now, what can you do these? Obviously, you can actually do this because there is a lot of skills that you probably already have. And if not, it just becomes challenging and something that you can actually develop and become better. And some of the skills that you should have, probably you already have a sense of it, is have excellent mathematical skills as well as IT. You should be good at problem solving and logical thinking, strong decision making, ability to analyze and interpret data. Every time you see a graph and you understand the implications of why CO2 is going up as a function of global warming goes up as a function of temperature, and you understand the correlation, that's something very, very important. The ability to assess complex problems and provide practical solutions. Commercial awareness, we need to understand what society actually requires, as well as budgetary skills. We need to make things in a cost-effective manner. Be able to work in teams, and people skills is also very, very important. We cannot solve the big challenges alone. We need to talk to people. And I believe the biggest thing among all of these is to be motivated to tackle the big challenges, okay? To be motivated, to have the passion, the energy to change the world. That's what you require to become a chemical engineer or an engineer in general. Apologies, I'm always so but engineering, you want to have that motivation. And the big challenges are these. As I mentioned at the beginning of the talk, I want to make you aware of what the UN Sustainable Development Goals are, okay? And in general, these are 17 goals, okay? There are 17 goals that were shaped by the United Nations. And the whole idea of these goals is what we need as human beings to progress, to move forward, to make the world a better place. Okay, so these are our objectives as humanity. And if you read a few of them, such as, for example, zero hunger, immediately we go back into the beginning when we talk about the nitrogen fixation process, create better fertilizers that are sustainable, that can increase crops so that we can actually eat, good health and well-being, my research area, for example, is the application of artificial intelligence to discover new pharmaceuticals so that we can treat people and we can have a better health. Okay, that's the number 3. Let's take a look at another one. Clean water and sanitation. We talk about Abel Woolman with the water chlorination. Affordable and clean energy, that's very, very important. Decent work, we have industry, innovation and infrastructure, etc., etc. There's climate action number 13 for those interested in sustainability. So there's many things. These are the big challenges. From those 17 goals, there's 169 targets that we should aim for and 232 indicators. If you're not aware of them, I strongly encourage you to see what they are, learn about the Sustainable Development Goals, and just be inspired of what you can do. Think about what you can do to solve, to help getting these 169 targets done. Okay, we need to move forward as humanity. So yeah, engineering will help you to tackle the big challenges, and I believe the University of Bath is an excellent training center for you to develop these engineering skills. And in general, there's a lot of things that you should consider when choosing a university. And I'm just going to talk about a few. Student community, entry requirements, industrial placement, flexibility and holistic approach to learning. That's very important. Campus university, Bath, the city itself, UNESCO World Heritage, arts and sports. We have amazing facilities, by the way. I believe during the last Olympic Games, we won 6 gold medals. So we were very high in the world ranking against countries. I think we were top 5 or something like that at some point. So amazing. If you are into sports and arts, Bath is the place. And of course, a lot of student support. So I'm going to talk about the top 3, right? So entry requirements, industrial placement, and flexibility, holistic approach to learning. I think those are the ones that I am entitled to show you as an academic. So let's talk about admissions. Some of you might be wondering, okay, what do I need to get into Bath? So these are the typical admissions. I'm not going to read them all. I encourage you to go online, take a look at our typical offers. Everything is online these days, so just go ahead, read them. But for example, I'm just going to focus on chemical engineering, which is the one that I am most familiar with. Okay, so we require an A-star AA in 3 A levels, including chemistry and mathematics. Okay, so we require that, your A levels. Or we require also 36 points overall and 766 in 3 higher level subjects, including chemistry and mathematics. So here's something that, for example, in chemical engineering, we highlight is obviously, you look at it, mathematics and chemistry. If you look at each of these, civil also requires A levels, for instance, in mathematics, electrical also mathematics, mechanical also mathematics. So mathematics is really, really the key language that we all use to really be able to communicate. Okay, we use mathematics as the language of science, and that's very critical. Okay, we are numerical focused, so that whenever you feel to study engineering, you really need to polish your mathematical skills. That's the biggest advice I can share with you. All right, so this is our typical offers. And I'm just going to give you an example of how our programs work, okay? In particular, I'm just going to focus for chemical engineering because we don't have much time. And that's the one that I actually know the best. So most of our engineering programs are accredited. In our case is the Institute for Chemical Engineers. And the way they are shaped, at least chemical engineering, is year 1, we call it the transition year or introductory year, where we understand that a lot of our students have different backgrounds or different levels of understanding of science and mathematics and other skills, such as programming, for instance. So that year 1, we make sure that your fundamentals of mathematics, science, and some engineering is there, okay? So you should not worry too much about, oh, but I did not study biology, or I am things like, don't worry, we're going to make sure that you get those basics fundamentals, and we're going to push them further. Year 2, we train you with the fundamentals of engineering. We really want to make sure that you understand everything related to, in this case, chemical engineering. Once you have your fundamentals, you go into your year 3, and you do some project design, you do some advanced courses in chemical engineering. And at that point, once you finish your design project, you are ready to graduate with a bachelor's in engineering, so a BEng in chemical engineering, okay? So we do offer a 3-year course in with a program with bachelor's in chemical engineering, and that's just 3 years. Now, let's assume that you want to have work experience, okay? Oh, apologies. If you want to expand your degree and you want to actually go for a master's in engineering, an MEng degree, you can go for the 4th year. And that's another program we offer, okay? That's the second. That's BEng in chemical engineering, which is 3 years, MEng in chemical engineering, that would be 4 years. Now, if you want to specialize in environmental engineering, then you can do an alternative. Instead of taking courses related to chemical and MEng in chemical engineering, you would do courses specific to MEng in chemical engineering with environmental engineering, okay? So far we're offering 3-year course in BEng, chemical engineering, 4-year course in chemical engineering, as well as a 4-year in MEng, chemical engineering with environmental engineering, okay? Now, here you would get your M standard. And of course, there's also the possibility to do a BEng placement, which you will do after your 2nd year, and also an MEng placement after your 3rd year, okay? So obviously, if you decide to do a BEng, so this program of its 3 years plus your placement year, that would be a 4 years course, okay? If you decide to do an MEng with placement, that would be 5 years that you would be working with us, okay? So this is just an example of roughly how placements and programs are shaped across the Faculty of Engineering at the University of Bath, okay? As I mentioned, year 1 and year 2, we focus a lot in talking about the fundamentals of engineering. Just to give you more depth into understanding what do I mean by that, you will study topics related to reaction engineering, science for engineering, material and energy balances, safety and ethics, fluid mechanics, engineering thermodynamics, process monitoring and control, and portfolio. So if you think about it, it is a transition, but still we go in depth and it's quite rigorous. The difference between our MEng in chemical engineering and MEng with environmental engineering, it's all about the alternative courses that you can take in your final year. For example, chemical engineering focuses more on subjects such as microprocessing, tissue engineering in the case that you like the biomedical aspects, as well as biomedical engineering, biorefining, biorenewables, now very critical if you want to produce bioplastics or you want to recycle things through biotechnology, advanced process modeling, law legislation, and waste management. In contrast, environmental engineering in this case, you focus on taking microbiology and ecology, macroeconomics, environmental law and legislation, and of course, a lot of things about environmental technology, okay? So this is the way we shape chemical engineering, okay? If you're interested in other engineerings, I strongly encourage you to go into the website at the University of Bath, Faculty of Engineering, and take a look at how each department actually shapes their programs, okay? Placements. We talk a little bit about placements really briefly. So the Faculty of Engineering has placements, and this is an amazing opportunity that you can do while studying. It's all about applying academic knowledge to industrial situations. Really, what we've seen is that the added value for when students do placement is how they increase their maturity and really self-confidence they gain by actually starting their career before they are in the job market. Our students become much more employable after doing a year-long placement. sometimes they even receive an offer during their placement, so they finish their degree and then they can go back to the company that they're actually working in. Obviously, you can earn money while being educated, which is an amazing thing to do. It helps you to start working. In the case that you want to become a charter engineer, this also counts for your chartership. And of course, it's all about exploration. It's all about looking at what you actually like, where you want to make impact. So it will help you to confirm your career's aims as well as discover new ones. Okay, so it is really amazing times to do this industrial placement. There is many industries where our students work: chemical products, design and manufacturing, pharma, consulting, oil and gas, food, beverages, many. Okay, and of course, these are some of the companies that we have partnership with, and we have an amazing industrial placement office that focuses on developing partnerships with different companies, as well as helping you to shape your CV, to polish your interviewing skills, your presentation skills, so that you are successful when applying to any of these placements. Okay, so we have a very, very strong Faculty of Engineering Industrial Placement Office. In fact, at least for chemical engineering, the number of applicants, as far as I remember correctly, students that actually work with the placement office and are aiming at getting a placement, I believe the success rate is about 80%, plus minus. So it's really high. So there's a great opportunity. Now, in reality, you can just think about engineering. Where can it actually take you? It can take you anywhere you want. It can get you to research, to do a lot of industrial work, start your own business, work in many companies. And it's all about the life experience when you actually graduate and the time that you spend at Bath. Here is some of our, this is a chemical engineering ball that we have every year. It's not all about working hard, which is part of it, of course, but it's also about enjoying your time at Bath. Perhaps you can see me here. Yes, I am on the top picture, top to the right. I am the third one from right to left, right here. A little bit younger, shorter hair. So yeah, amazing times here at Bath. And I think the final points that I want you to consider when choosing a university is that you should look for exposure to professional business skills, group projects, and individual projects. Is something that you want for enhancing your employability skills. You want a university with strong links with industry and commerce. You want the opportunity for placements. I think that's very, very important. It really helps your employability as well as your development as an engineer. You want programs that are accredited, such as the ones I mentioned, Institute of Chemical Engineers and others. You want to look in the league tables for teaching quality, okay? You want to make sure that you will receive high quality teaching and you will be able to learn and train yourself as an engineer. Now, look for flexibility, okay? Options to change if you are unsure of what to do. For example, you are a BH, you want to switch to MEng. Will that university allows you to have such flexibility to change programs? Look for the essential study facilities. How are the facilities of that particular university? Will I actually be happy studying in that place? And finally, look for what matters to you. It's all about you. Don't think too much about the friends that you have. This is an amazing opportunity to make new friends, meet new people, and expand your horizons. So just a really quick video so that you understand one little bit more of what chemical engineering is, not from my words, but from our students. Let's see if you can hear this. Let's see, click.
Chemical engineering really is at the heart of sustainability. So if you're going to create a renewable solution for the world, you're going to need a chemical engineer.
Chemical engineering is a really unique degree in that you're going to be at the centre of many different projects. That means that you'll have to have a good theoretical knowledge of the processes that are happening, but you'll also get to apply this to a real process.
It's a very hands-on experience. They have us doing labs and writing reports, even from the first year. It makes you feel less like a chemist and more like an engineer.
You really solve real-world problems right from the outset. There's a lot of group work, so it means that you're also learning with a group, but Bath is really prized for its research, so balanced it out with individual work. We're also taught and encouraged to look at the ethical aspects, at the environmental aspects, and at the safety aspects. So it means that when we come out and actually join the real world, that we really are all-rounded engineers.
We cover units such as law, management, as well as the more technical aspects of things, so it gives you a much better basis to go into the working world. This semester I've been working on a research project. I was trying to design a multifunctional face mask that could remove carbon monoxide and heat from air in a fire situation. It gave me a lot of flexibility, and I learned how to self-motivate myself, and the lecturers have an open door policy, so they're pretty much there to help all the time.
Chemical engineering, in my eyes, is one of the most broadest paths of engineering. On my industrial placement, which spanned 12 months, I was working as a continuous improvement process engineer. It's really taught me a lot of soft skills about being in the workplace. But you can literally work in biomedical field, in the food field, in water engineering, you name it. The world's kind of your oyster as a chemical engineer.
Chemical engineers are vital to moving towards a more sustainable future. One of the things we're told is that we turn ordinary stuff into good stuff without producing any bad stuff.
It makes me really proud to know that at the end of my course that I'll be part of a huge band of engineers who are really changing the world.
All right, sorry, I have to give a little advertisement of chemical engineers as that's where that's my home. So yes, so engineers, final messages, work towards a sustainable future. The well-organized course on world-class research at Bath is something that you should consider. And remember, narrow down your options and make your own decision. Okay, that's the most important thing. Thank you very much for listening. And of course, please take a look at Bath if you have any questions. And thank you very much. Happy to answer any questions you might have at this point.
Thank you, Dr. Dominguez. That was fantastic. I unfortunately missed the first 5 minutes, but what I heard was absolutely brilliant. We have already got some questions coming. I'll put to you as well. But yeah, I really appreciate it. I think the emphasis, particularly on the kind of the work and the experience, is really important. Something we're doing particularly with Year 12 students right at the moment. So we've got a couple of questions I can run through from the chat for you here. So the first one we got here is about, I guess, mechanical engineering specifically, and what students can do in high school at the moment. So, obviously, you've got students here probably going across GCSE and A level at the moment on this call. So what sort of things they can be doing to prepare for something like mechanical engineering?
So for mechanical engineering, I think I'm gonna shape it in general, right? For in general, for whether you want to apply for chemical, mechanical. I think one of the things, as I mentioned, is to really make sure that your fundamentals of mathematics are there. Make sure that you study hard your mathematics. Make sure that you get the marks required for the entry requirements. So that's key. Now, if you want to expand further, really start looking into why you want to study such degree. You will have to write a statement or a motivational or a statement of purpose, why you want to study mechanical engineering, chemical engineering. And really, you have to be honest with yourself. You need to inspire us of what you want to do. And how can you need to be able to justify any statement that you want to make. For example, you say, I like cars. Okay, why do you like cars? Have you had any experience working with cars? What have you done that you like the car so much? If you do not have such backup or justification why you like things, perhaps you are not sure whether you actually like it. So I strongly encourage you to see whether you can get a part-time job, whether you can actually go a little bit more in depth, do a research project with one of your professors about a particular subject that might help you to really understand whether that's where you want to go. So write the strong motivational letters, and whenever you do not feel that you have the support, try to explore whether that statement that you wrote is true. And that's what I encourage you, to make sure that any motivations you take are backed up by facts rather than by a belief that you are not quite sure.
Fantastic. And obviously we're about to start personal statement writing, and that's gold dust. in terms of advice there. So follow that exactly. And a bit of a spin on from that, really, because the question here as written is how much of the course is coursework and how much is paper-based? I suppose maybe another way of asking that is how much of it is a vocational pathway and how much of it is an academic pathway? I mean, what is the kind of balance on the program for you? Or does it differ between the different areas?
That's an excellent question, and I think it's an extremely difficult question to answer as it changes depending on what you're studying. It also changes based on where you are in your degree. As probably you saw in the video, from the get-go, you will go to the labs, you have practical work to do, you have design projects, research projects, a lot of teamwork-based learning, problem-based learning. So a big chunk of it is coursework. I believe from year one, perhaps let's focus on one. Let's focus on, just to give a concrete example, chemical engineering program, year one students, okay? About 40% is coursework, is assessed through coursework. Let's notice, assessed through coursework, and 60% through an actual paper-based exam, okay? However, that changes. For example, in year 3, it's all about coursework. It's all about your design project. How do you do your design project? Can you actually make a product and show us something more tangible? So it changes in a year-by-year basis, and also will change depending on what you're studying.
Okay, so I think that gives it a fairly kind of clear outline as to what it would be. And I think, I guess, again, kind of nicely following on as well, it's just about how students tend to manage their time with that, because, and I think a lot of students here might be doing a combination of A-levels. For example, a common one for engineers might be maths, physics, and say design technology. And obviously you've got quite a mixture of different things, and the time management's quite key. How do you find students cope with that, with these very different elements from module to module?
Yes, so obviously our program is very well structured to make sure that there is a huge degree of alignment, we call it, where concepts that you learn in mathematics are not decoupled whatsoever on what you learn about fluid mechanics or any other subjects. So anytime you learn about a particular subject, we will make sure that you revisit it elsewhere, and that everything is very well integrated, not only horizontally, meaning that within the same academic year you will learn, I don't know, mathematics, biology, chemistry. All of those subjects will be talking to each other. So you will apply mathematics and biology with a little bit of chemistry to solve a problem. That's horizontally as well as across your degree. So concepts that you learn in year 1, you will see them again in year 2, and you will see them again in year 3 and 4. So it's all about scaffolding, making sure that the time management will not be an issue for you. So our program, first of all, is very, very well structured. Now, usually if you look at you can always look at our programs. Particularly, I'm going to talk about from the chemical engineering perspective. In reality, we have 4 modules only for year 1, for example. We have the fundamentals of science, fundamentals of engineering, we have a portfolio, and we have, I forgot the last one. But if you think about it, it is not massive in terms of the number of subjects that you have. It will not differ much more of what you already have in your A-levels in terms of number of subjects. So my suggestion is, obviously you will require discipline to make sure that you review the concept, you study on your own time, but usually contact time hours are limited to 20 hours per week. And then the rest is we give clear guidance into how to study, how to approach your learning. If you follow that recipe that we give you, you will not have trouble in terms of time management.
Fantastic. Now we've got a question here about another area of engineering that maybe I didn't hear in that presentation, but in terms of biomedical bioengineering, it's obviously been quite a massive growth area over the last few years. Is that something that Bath specifically offer? And maybe if they do, or if not, maybe you could just go into a bit more detail about exactly what that does entail.
Yes, so bioengineering, biomedical engineering, biotechnology. So these are subjects that uses biology to apply it to solve engineering problems, whether it's in healthcare or bioresources, as I mentioned in one of the slides in terms of environmental engineering. So chemical engineering does have a lot of its curricula focused on biotechnology, bioprocess engineering, biomedical engineering. Yeah, so usually most of our learning will be problem-based learning, and year one focuses quite a bit on bioprocess engineering. In fact, one of the topics that you will learn immediately from the get-go in year one is bioprocessing and biotechnology. And as I mentioned, that expands throughout the next years. So we do have a big chunk of our degree, chemical engineering, focusing on biotechnology, biomedical engineering. However, we want to give you the experience to also look into other subjects, not only focusing on biomedical engineering or biotechnology, but definitely you will get the grasp and the fundamentals so that in the case that you want to specialize in that particular area, you can easily do so. Or if you want to work in such industry, no problem. You will have the fundamental skills to go in that area. Now, to push it forward, for example, in an MEng degree, you can do a research project with one academic, for example, such as myself, and you are really keen to learn more about biotechnology to an extent you want to become an expert in biomedical engineering, for instance. You can actually do research one semester full-time with one academic in that particular field to make sure that your area of study is completely polished in whatever area you actually want to go to. So our program is sketched in such a way that if you are particularly interested in one subject and sub-specialization of chemical engineer, you can actually get that training in that area.
Okay, fantastic. Okay, I think that's pretty clear, very comprehensive answer, I think, on that. And again, of course, contacts for all of us, myself and everyone else on the call from Bath. If you want to find more about that, that's absolutely fine. It is a very, a popular route, certainly in terms of the conversation I'm having with students a lot. I think just to kind of round up at the end, obviously, if anyone's got any further questions, please do add them to the chat function and we'll get those in before the end. But we normally like to ask anyone really that comes onto one of these sessions a bit more about the future. So obviously most of the students on this call would be graduating between kind of 5 to 10 years time and going out into the workplace. I mean, as you've already pointed out really nicely, I think obviously they can be going into lots of different sectors. But for those staying within engineering, what do you think the kind of key challenges are going to be? I mean, where are going to be the areas of kind of high recruitment? What are going to be the things that maybe particularly in the UK, but possibly if you're able to, even in Southeast Asia, Malaysia, do you think are going to be the big issues?
That's a very interesting question, quite challenging, as this puts me from an engineer to a visionary of the market. And I think I believe that if you look at what I show you about the Sustainable Development Goals, it's really a huge window into what is to come and what it's something that we need to be working on, and where policy will become more stringent for employability. So any of the areas related to the Sustainable Development Goals are hot topics or hot areas, and it's just the right place to be in at this moment and to begin your degree. Areas related to healthcare, obviously, and sustainability, healthcare, and digital technologies is something that are becoming more present in our daily life. As I mentioned, for example, technology. I'm speaking from Mexico. You guys are in Malaysia. Shaban is in the UK. So we are all across the world. So digital technologies become quite more used for different applications. So that's an area that is moving forward quite quickly. Sustainability, as I mentioned, and not for everyone forever. Climate change. Yeah, it is very tricky. It is so broad, but the big challenges and the places to be or to tackle are clearly outlined by the UN Sustainable Development Goals.
I mean, I'd say a lot of people here, obviously we're speaking from a real kind of petro economy here, as are you in Mexico. So I'm just wondering from that perspective, a lot of those students looking at chemical engineering going forward, do you think there will be those jobs, or will those jobs still be there, but just incredibly different maybe to the ones that there are now?
That's an excellent question. And I think rather than focusing on chemical engineering as a subject or mechanical or civil, what students should consider when it comes to engineering is their training. The engineers of the future are not those who are specialized in a particular subject, but rather those who can learn, unlearn, and relearn. Okay, and that's something that we put emphasis in our program. We want to make sure that you can have that capability of adapting to the environment and learn new things. And it's all about your logical thinking and how you approach solving problems. The title of chemical engineer is all about roughly what area or related to chemicals or stuff, as I mentioned, that you like solving this type of problems. However, by no means it restricts you whether you want to solve issues related to electrical engineering or mechanical engineering. It's all about interdisciplinarity. But so the market will continue growing for engineers in general. The names might change, but the training will be the same. That's my opinion.
Okay, fantastic. Listen, I think we can leave it there. There's any more questions at the moment. Listen, thank you everyone for joining us. It's really interesting, really insightful. I think the technical information you've got there is incredibly clear. So if you did even want to come back and review this again, if you're thinking of applying, this will be a really useful tool. I think this will be available on our YouTube site and recommend to anyone else, because the clarity of those different options, which can be confusing when you first come into them, was very good there. So massively appreciate that. If it's okay, Dr. Do, are you okay just to stay for another few minutes? We're going to have a quick chat. Just to say to everyone else on the call, if you did want to ask a question in person directly, you didn't want to do it in the group, you can do that now if you want to stay on. So by all means, just stay onto the call now, and you can talk to myself or Dr. Dominguez directly. Otherwise, really appreciate you coming and joining us today. Thank you so much, and we'll see you again soon. So thank you very much. Unless you have a question, you can leave the call now.